Alrighty, tonight we're going to be talking about unit conversions and the metric system. That up in the corner. Okay, so the metric system and SI units. The metric system is a way of standardizing measurements around the world, especially in the scientific community. In 1960, the International Committee on Weights and Measures, which sounds like just about the most fascinating committee to be on, adopted a modern system of measurements known as the System of International Units, or SI units. The scientific community has backed the SI system, and all measurements taken in science, regardless of where you live, are measured using SI units. All forms of measurements have base units, especially in the SI system. Now, mass is the only one that I disagree with the base unit. The base unit of mass is technically the kilogram. However, I pretty much fundamentally disagree with that because that puts a prefix in front as a part of your base unit, and I pretty much disagree with that, but I can't go against the world. So we are going to say that the base unit for mass is kilogram. The base unit for time is seconds. For volume, it is liters. For distance, meters. And for temperature, it's Kelvin, or more commonly, Celsius. Now, either one of these can be considered the base unit. They both have increments, are incrementally increased in 1 degree Celsius, or sorry, in 1 degree increments. And so they're both acceptable. Kelvin usually has higher numbers because it starts out at room temperature is, I think, it's like 275 Kelvin. So we don't typically use that. We use Celsius because it's an easier one for us to manage with smaller numbers for the science world. However, many measurements in science are much smaller or larger than the base unit, and so we have to attach a prefix to that base unit. So let's talk about prefixes. We have a nice long spectrum here, and this is where our prefixes are going to go, and these prefixes are attached to the beginning of all the base units, except for, of course, mass, because the mass already has a prefix attached to it, so it's going to be, the prefix is already there. The kilo is the prefix to the gram. So here you'd have your base unit, and that base unit would be something like volume for liters or meters or what have you. On the larger end, so these are things that are larger than the base unit, you have deca, hecto, kilo, which is 10 to the 3 times larger than the base unit, or mega, which is 10 to the 6. Sorry, guys. On the smaller end, you have deci, or deci, centi, which is 10 to the negative 2, milli, which is 10 to the negative 3, micro, which is 10 to the negative 6, and that unit right here is it's micro. It looks like a U with a tail or an M with a tail. It kind of depends on how you draw your M's. Or nano, 10 to the negative 9th, or pico, 10 to the negative 12th. Now, not all of these are important for you to remember, so let's highlight some of the important ones. On the large side, kilo, 10 to the 3, that is important. Mega, 10 to the 6, that is also important. Those are the two main ones on the higher end of the spectrum that you need to be worried about, or even consider memorizing their 10 to the 3 and 10 to the 6 indications. On the lower side, you have centi, 10 to the negative 2. We use centi a lot in centimeters. We have milli, 10 to the negative 3. We use that a lot in volume with milliliters. We have micro, 10 to the negative 6. Nano, 10 to the negative 9. And pico, 10 to the negative 12th. As you can see, there are a lot more that we're concerned about you knowing on the smaller end than the larger end, just because we deal a lot more on the smaller scale here in school than the larger scale. Excuse me, I have hiccups. Alrighty, so let's talk about converting between metric units. Oftentimes, you will encounter situations where different prefixes are used in the same problem. You can convert from a base unit to a prefixed base unit, and vice versa. So, for example, if I wanted you to tell me how many milligrams there are in 56.91 grams, you would have to go through a process like this. So we can see that we remember from our little range that milli is 10 to the negative 3. So there are 10 to the negative 3 grams equal to 1 milligram, or in 1 gram, there are 1,000 milligrams. Now, these are two different ways to look at it. So if you're going with a small number, there are very few grams in 1 milligram, but there are a lot of milligrams in 1 gram because milli is a lot smaller than the gram. So we take our 56.91 grams, and we're going to multiply it by this unit, this conversion factor, 1,000 milligrams per 1 gram. As you can see right here, this gram, since it's on top of the fraction, is able to be canceled out by this gram on the bottom of the fraction, leaving us with milligrams, the units that we want. And if you type that into your calculator, you type 56.91, multiply everything on the top, and divide everything on the bottom. So 56.91 times 1,000 divided by 1 is 56,910 milligrams, or 5.691 times 10 to the 4 milligrams in scientific notation. So the other way to look at it is you have 56.91 grams, you have 10 to the negative 3 grams, and 1 milligram. It's the same thing where we're canceling out the grams on the top with the grams on the bottom, leaving us with milligrams, and we get the same answer. It's just a different way of looking at what conversion factor are you using. So our answer is 56,910 milligrams. This right here, and also this on the bottom, this fraction is called a conversion factor, and that is the essential part in converting between metric units. You always need a conversion factor. This conversion factor is typically 1 over a number, and a lot of the times if you're just strictly in the metric units, it's going to be 1 over like 1,000, 100, what have you, okay? So that's what a conversion factor is. So I want you guys to do some practice. So right now, write down on a piece of paper, take out a piece of paper, and write down 16.34 meters, and calculate for me how many nanometers that is. I want you to pause the video now and do that calculation. You should be pausing. All right, now that you've done that calculation, let's check back and check if we agree. So a nanometer is 10 to the negative 9, so there are 10 to the negative 9 meters in 1 nanometer, or there are, that's a billion, right? 100,000, no, that's a million, sorry. 1 meter is equal to 1,000,000 nanometers. So if we have 16.34 meters, I'm going to put in my conversion factor there of 10 to the 9 nanometers in 1 meter. My meters cancel out, leaving me with nanometers. And my answer is 1.634 times 10 to the 11 nanometers. So that's a whole heck of a lot of nanometers in a meter. And this makes sense because we know that nano is smaller, and so there should be a lot more of these for this because it's a lot smaller. Alrighty, let's go ahead and convert 123 kilometers into meters. 123 kilometers into meters. Pause the video now and please convert that. Alright, now that you're done, let's check it out. That should be 10 to the 3 kilometers. I'm sorry, I forgot to superscript that. Is equal to 1 meter, or in 1 kilometer there are 1,000 meters. So we have 123 kilometers. We're going to use our conversion factor of 1,000 meters in 1 kilometer. Cancel out our kilometers and our kilometers, leaving us with meters. And our answer is 123,000 meters. And this makes sense again because meters are smaller than kilometers. And so there should be a lot more of them in a meter, or a lot more meters in that many kilometers. Sorry, I know that was kind of confusing. I fumbled that, but we're going to carry on. So large conversions between metric units. Sometimes I'm going to ask you to go from a prefixed unit to another prefixed unit. Here it technically is the base unit, but I disagree with that, so I'm saying that is a prefixed unit as well. Or another prefixed unit to another prefixed unit. This, oftentimes, what I do and what I find is easiest is to go from one prefix to the base unit and then to the next prefix. If you're comfortable and you know exactly how many steps it takes to go from one prefix to the other, that's fine, but you need to show your work. And for me, it's just always easiest to go back to the base unit. So let's look at this. So I have 879 nanograms. I know that there are 10 to the 9 nanograms for every 1 gram and 1,000 grams for every 1 kilogram. So my nanograms canceled out, my grams canceled out, and I was left with kilograms. And so my answer, I just take everything on top divided by everything on bottom. So 879 divided by 10 to the 9 divided by 1,000. And the reason why I didn't times by 1 and times by 1 is because I know that anything times by 1 is itself. So we get a very small number. Now this makes sense because we went from a very small amount to a very large unit, and so it should be much smaller. 8.79 times 10 to the negative 12. All right, let's look at taking kilometers and converting it to centimeters. So we're going from a large to a small. So we have 1.58 times 10 to the negative 8 kilometers into centimeters. So I'm going to go from 1.58 times 10 to the negative 8 kilometers, convert those to meters, my base unit. There's 100 meters, 1,000 meters in 1 kilometer, and then convert that base unit into centimeters. And there are 100 centimeters in 1 meter. My kilometers are able to cancel out, and my meters cancel out, leaving me with centimeters. I take everything on top and multiply it together and divide by 1. Everything on bottom is 1, so 1.58 times 10 to the minus 8 times 1,000 times 100 gives me the answer of 1.58 times 10 to the minus 3. Now this also makes sense because this is a smaller number, or sorry, a larger number. It has a smaller exponent. It is a larger number than this because we're taking a very large unit where we had a very small amount and going to a smaller unit, so there should be more of it. We can also use unit conversions to go into other aspects of science and life and using non-metric units. So for example, I could get from 15.8 feet and convert it into centimeters. So the way I would do this is I would take my 15.8 feet and I'd multiply it by a conversion factor. Now, the issue here is trying to figure out what conversion factor we have. So I'm going to take it from feet and break it down to inches because I'm pretty sure that inches are going to be easier to deal with. And so I know that for every 1 foot, I have 12 inches. Then I looked it up and I found a conversion factor from inches to centimeters, and I found that there are 2.54 centimeters for every 1 inch. So my feet canceled out, then my inches canceled out, leaving me with centimeters. So I'm going to take everything on top and multiply it and everything on bottom and divide it. And so it's 15.8 times 12 times 2.54 divided by 1 gives me my answer of 482 centimeters. Note my significant figures here. I only had 3 significant figures here, so my answer has to be recorded in 3 sig figs. So 482 centimeters. This also makes sense because a centimeter is smaller than a foot, and so there should be more of them. All right, what if we wanted to convert 29 seconds into weeks? So I would take 29 seconds. Now I need a conversion factor to get from seconds to weeks. Now some of you may actually know how many seconds there are in a week. It may be some fun fact that you picked up along the way. But for those of you who don't, I like to take things in small increments. And so I'm going to convert seconds to minutes because I know that conversion very well. That conversion factor is that there are 60 seconds in 1 minute. So I'm going to convert from seconds to minutes, and then I'm going to convert from minutes to hours. I know that there are 60 minutes in 1 hour. I also know that there are 24 hours in 1 day and 7 days in 1 week. So my seconds were able to be canceled out, then my minutes, then my hours, and then my day with my days, leaving me with weeks. And if I multiply everything on top and divide everything by bottom, I get 29 divided by 60 divided by 60 divided by 24 divided by 7 gives me 4.8 times 10 to the minus 5 weeks. So 4.8 times 10 to the minus 5 weeks makes a lot of sense because it's a very small number. We went from 29 seconds, and 29 seconds is a pretty small number, to weeks, which weeks is a very large value in comparison. And so 4.8 times 10 to the minus 5 weeks makes sense. All right, I know that that was a lot to go over. You may need to go back and view that again. But the important thing to take from this is the idea of conversion factors, and that we need to find those. And I need you to start memorizing those metric system prefixes. I'd like you to have a chart written down with those prefixes, maybe on an index card, that you can use in class to reference so that you'll be able to go through these practice problems. We're going to do some practice problems on Monday, and we'll get down conversions. Any other things that you want to, any other conversion factors that you know of, like the centimeters and the inches, if you want to look those up and find out any neat ones to put on your note card, that would be fine too. Otherwise, I hope you guys have a good weekend, and I will talk to you on Monday. I have to stop this though, and I don't know how, apparently. Where's my guy? There it is. Alrighty, thanks guys.